Here we have a SAT math problem. Okay, let's go with the question. If 4 to the x power equals to 5 to the y power equals to 20 to the z power, what is the value of 1 over x positive 1 over y negative 1 over z? Okay, we have to consider the equation we have over here. Using this equation, we have to get the value of this expression. Okay, now let me take this equation as it is. It is 4 to the x power equals to 5 to the y power equals to 20 to the z power. Okay, what is the value of this 4 to the x power? Actually, it is not given in the question. For example, if I assume k, the constant k is the value of this 4 to the x power, then what must be the value of this 5 to the y power? So the value of this 5 to the y power also must be k, and the value of this 20 to the z power also must be k, because all of them are equal. So if the one of the quantities is having the value k, then the other two quantities also must be having the same value k, because all of them are equal. So now let me assume all the three quantities are equal to k. Since all of them are equal to k, we can equate each quantity to k over here. There is 4 to the x power equals to k, and 5 to the y power equals to k, and 20 to the z power equals to k. Now, in this equation, I am going to raise both sides to the power of 1 over x, because I want to get rid of the exponent x over here. Okay, let me do it. 4 to the x power is raised to the power of 1 over x. The same thing on the right side, that is k to the power of k raised to the power of 1 over x. Okay, here we have base 4 and we have exponent x, and for this complete stuff we have exponent 1 over x. Whenever we have two exponents like this, what we can do is we can multiply the two exponents using the power of a power rule in exponents. That is 4 to the power of x times 1 over x, and on the right side we can write this stuff as it is, that is k to the power of 1 over x. Here this x and x will cancel out, we get 4 to the first power. 4 to the first power is just 4, and on the right side we have k to the power of 1 over x. Okay, now we can do the same thing over here in this equation. When I do so, I'll be getting 5 equals to k to the power of 1 over y. And also when I do the same thing over here in this equation, I'll be getting 20 equals to k to the power of 1 over z. Now we can write this 20 as 4 times 5. And on the right side, we can write this stuff as it is, that is k to the power of 1 over z. And we know that 4 equals to k to the power of 1 over x, and 5 equals to k to the power of 1 over y. Now we can plug in this k to the power of 1 over x for this 4, and k to the power of 1 over y for this y. Then I'm getting k to the power of 1 over x times k to the power of 1 over y equals to k to the power of 1 over z. Okay, here we multiply two terms with the same base, that is k. Okay, according to the product rule of exponents, whenever we multiply two terms with the same base, what we can do is we can take the base ones and we have to add the exponents. Then I'm getting k to the power of 1 over x or positive 1 over y. On the right side, we have k to the power of 1 over z. Okay, here two terms are equal with the same base, that is k. Whenever two terms are equal with the same base, what we can do is we can equate the exponents. Then I'm getting 1 over x positive 1 over y equals to 1 over z. Okay, now let me subtract 1 over z from both sides of the equation. When I do so, this positive 1 over z, negative 1 over z will cancel out. Then I'm getting 1 over x, positive 1 over y, and negative 1 over z on the left side. On the right side, we have 0. Okay, now I got the value of this expression, 1 over x, positive 1 over y, negative 1 over z. Its value is 0. We find this 0 in answer choice B. The correct answer choice for this question is B.